Chapter 5 Photosynthesis. Definition. Photosynthesis is the anabolic process in which complex organic substances are synthesized from CO2 and H2O in presence of light and chlorophyll. Photosynthesis is a redox reaction where water is oxidized to liberate oxygen and carbon dioxide is reduced to form carbohydrates. Site for photosynthesis is chloroplast. The chloroplast is double membrane cell organelle. The membrane is called peristonium and it is made up of lipoprotein. The matrix is called stroma. It contains enzymes for dark reaction. 40 to 60 disc-like plates called grana or granum are suspended in stroma. They are connected by intergranule or stroma lamellae. Each granum is a stack of thylakoids. Thylakoid membrane contains quantosomes, where light reaction takes place. Each quantosome has 230 to 250 molecules of chlorophyll. Photosynthetic pigments. The pigments involved in photosynthesis are called photosynthetic pigments. These are chlorophyll A, chlorophyll B, carotenes, xanthophylls. Chlorophyll A is called center of reaction as it can convert solar energy to chemical energy. Other pigments are called accessory pigments or antennae pigments. Photosystem, a group of photosynthetic pigments that trap light energy and convert it into chemical energy, is photosystem. There are two photosystems, PSI. The reaction center in this group is P700. P stands for pigment and 700 for wavelength of light it absorbs. PS2. The reaction center in this system is P680. Mechanism of photosynthesis. It is completed in two phases, light reaction, dark reaction. Light reaction or photochemical phase. It is light-dependent reaction occurs in grana of chloroplast. Chapter 4 Electrochemistry. Introduction. Electrochemistry deals with the interconversion of electrical and chemical energy. Electrochemistry is of enormous commercial importance because of the costly destruction caused by corrosion and the exciting possibilities of fuel cells which generate electricity directly from fuel. There are two types of chemical reactions, spontaneous and non-spontaneous. Spontaneous chemical reactions take place on their own accord from which electricity can be generated. Non-spontaneous chemical reactions need external help. By supplying electrical energy, chemical reactions take place. In electrolytic cells, electrical energy is converted into chemical energy. Example, electrolysis of fused NaCl in which Cl2 is liberated at anode and Na deposits on cathode. In electrochemical cell or galvanic cell or voltaic cell, Zn is used as an anode while Cu as cathode and chemical energy is converted into electrical energy. Electrolysis is used in electroplating, electrorefining and electrotyping. There are two laws of electrolysis known as Faraday's laws. Faraday's first law of electrolysis. The amount of any substance deposited or dissolved is directly proportional to the quantity of electricity passed through it. W is directly proportionate to Q. Therefore, W is directly proportionate to IT as Q is equal to IT. Therefore, W is equal to ZIT. Z is equal to proportionality constant, that is electrochemical equivalent. Chemical equivalent is equal to 96,500 multiplied by ECE. Faraday's second law of electrolysis. When the same quantity of electricity is passed through the solutions of different electrolytes, the amount of the products obtained are proportional to their chemical equivalent or equivalent weights. That is, W is directly proportionate to E. Therefore, W upon E is equal to constant. W1 upon E1 is equal to W2 upon E2 is equal to W3 upon E3. Summary. In this topic, we learnt about Faraday's first and second law of electrolysis, about electrochemical cells, types of electrodes, Nernst theory, etc. EMF series is used to find the relative strength of reducing and oxidizing agents in terms of EO values, selection of oxidizing and reducing agents, selection of electrodes, calculation of EO cells, etc. Lead accumulator consists of lead plates as anode and lead plates impregnated with PbO2 as cathode. 20% H2SO4 solution of specific gravity of 1.215 is used as an electrolyte. Also, in this topic we learnt about hydrogen-oxygen fuel cell and
trigonometric equations and its solutions. A trigonometric equation is a non-algebraic equation, a type of transcendental equation containing trigonometric functions of variables like x or y or t or theta. A principal solution of a given trigonometric equation is the angle x which satisfies the equation and which is such that 0 less than or equal to x less than 2 pi. If tan x is equal to 1, then the principal solutions are x equal to pi by 4 or x equal to 5 pi by 4. Thus, principal solutions could be finite or infinite, as in case of the trigonometric equation sin square x plus cos square x equal to 1. Find the principal solution of the equations 1. Sin x equal to root 3 by 2. Therefore, x equal to pi by 3 radians or x equal to 2 pi by 3 radians. Second, sec x equal to 2. This implies cos x is 1/2 and therefore x equal to pi by 3 radians or 5 pi by 3 radians.
Chapter 1 Continuity. Let fx be a real valued function if x equal to a is a point in the domain of f, that is, a belongs to D of f. Then the value f of a exists. If further limit of fx as x tends to a is equal to f of a, then we say that the function f is continuous at the point x equal to a. In this case, the graph of the function will also be continuous at x equal to a. If f is not continuous at x equal to a, it is said to be discontinuous at x equal to a. In this case, the graph will show a break at x equal to a. Let us now understand the concept of a left hand and a right hand limit. Let x tends to a and be such that x is less than a. Then we say that x tends to a from the left hand side, and we denote it as x tending to a with a minus sign on the top. Second, let x tends to a and be such that x is greater than a. Then we say that x tends to a from the right hand side, and we denote this as x tending to a with a plus sign on the top. One-sided limits of fx. A. The left-hand limit of fx is denoted limit fx as x tends to a minus, and the right-hand limit of fx is denoted limit of fx as x tends to a plus. If the left-hand limit is equal to right-hand limit, that is limit fx as x tends to a minus equal to limit fx as x tends to a plus,
Circular motion. Introduction. Circular motion is the motion along the circumference of a circle. If the particle moves from A to B, then V is equal to S upon T is average speed of the particle. The position vector gives the position of the particle with respect to observer O. In this chapter, we will learn about basic concepts of velocity and acceleration, banking of rods, centripetal and centrifugal force, and conical pendulum. Explanation. Angular displacement. It is defined as the angle traced out by the position vector of the particle in that interval of time. Angular velocity. It is the time rate of change of angular displacement. Angular acceleration. It is the time rate of change of angular velocity at that instant. Relation between linear and angular velocity. Consider a particle moving in a circle of radius r. The linear velocity r is equal to ds upon dt. We know that ds is equal to d theta multiplied by r. Dividing by dt, ds upon dt is equal to d theta upon dt multiplied by r. V is equal to rw. Radial acceleration. The linear velocities pq and ca is equal to v. Take a point A and draw vectors ca and cb. Join AB. By triangle law of vectors, ca plus ab is equal to cb. A bar is equal to dv upon dt, and angle ACB is equal to angle POQ is equal to delta theta. AB is equal to delta V is equal to V delta theta. A is equal to dV upon dt is equal to V delta theta upon delta t is equal to VW. W is equal to V upon R. Therefore, A is equal to V square upon R. Summary. A particle performing circular motion along a circle with constant angular velocity is said to perform uniform circular motion. Angular displacement. It is the angle traced out by the position vector in that interval of time. Angular velocity. It is the time rate of change of angular displacement. Its unit and dimensions are radian per second and m raised to 0, l raised to 0, t raised to minus 1 respectively. The relation between linear velocity, angular velocity, radian vector is v is equal to omega multiplied by r. Angular acceleration. It is the time rate of change of angular velocity. Its unit is radian per second square and dimensions are m raised to 0, l raised to 0, t raised to minus 2. Questions. Define angular displacement. It is defined as the angle traced out by the position vector of the particle. Angular velocity. It is defined as time rate of change of angular displacement. Angular acceleration. It is defined as time rate of change of angular velocity. Prove that V is equal to Rw. Consider a particle moving along a circle of radius r. Let its mean velocity be ray v is equal to d ray s upon dt. The angular velocity of the particle b w is equal to d theta upon dt. From the diagram, d ray s is equal to d ray theta multiplied by ray r. Dividing by dt, ds upon dt is equal to d theta upon dt multiplied by r. Ray v is equal to ray w multiplied by ray r. Differentiate between centripetal force and centrifugal force. Centripetal force. It is a real force whose origin can be explained. Centrifugal force. It is a pseudo force whose origin cannot be explained. Centripetal force. It is directed towards the center of the circle. Centrifugal force. It is directed away from the center. Centripetal force. It is present in inertial and non-inertial frames. Centrifugal force. Its existence is considered in non-inertial frames. Short answer questions. What is banking of roads? Obtain an expression for angle of a banked road. In case of a curved road, the outer edge of the road is raised than the inner edge. This is called as banking of roads. Consider a car moving along a curved road. Let its weight be m. The forces acting on it are its weight mg, acting vertically downwards, and the normal reaction n, which can be resolved into two components n cos theta and n sin theta. Component n cos theta will balance the weight mg, while component n sin theta provides the centripetal force mv square upon r. Therefore, n cos theta is equal to mg, equation number 1, and n sin theta is equal to mv square upon r, equation number 2. Dividing 2 by 1, tan theta is equal to v square upon rg, or theta is equal to tan raised to minus 1 into bracket v square upon rg bracket complete. Centrifugal force is called as a pseudo force. Interference and diffraction. Introduction. If there are two or more waves, then each wave produces its own effect independent of the other. We will learn about superposition of wave, conditions of steady interference, Young's experiment, analytical treatment expression for bandwidth, biprism experiment. Explanation. Superposition of wave. When two waves arrive at a point, each wave produces its own displacement independently of the other. The resultant displacement at that point is equal to vector sum of displacements due to two waves. Conditions of interference. The two sources of light must be coherent. The two sources of light must be monochromatic. The two sources must be equally bright. The two sources should be narrow. The two sources should be close to each other. Path difference. is equal to 0, 2 lambda, 3 lambda and so on is equal to n lambda integral multiple of wavelength. Therefore, point is bright. Path difference is equal to lambda upon 2, 3 lambda upon 2, 5 lambda upon 2 and so on. Path difference is equal to n plus half multiplied by lambda, where n is equal to 0, 1, 2 and so on. Odd integral multiple of half a wavelength point is dark. Young's experiment demonstrates interference for first time. A pinhole S is illuminated by light from the sun. The emergent light is allowed to fall on two more pinholes, S1 and S2. These two pinholes act as two coherent sources and give rise to secondary spherical wavefront. Light front S1 and S2 produces a steady interference pattern. Summary. Superposition of waves. When two waves arrive at a point of the medium, each wave produces its own displacement of the other. The resultant displacement is the vector sum of displacement due to two waves. Conditions for interference. The sources should be coherent. They should be monochromatic. They should be equally bright. They should be narrow. They should be close to each other. The distance between two consecutive bright bands is called as bandwidth. Wavelength lambda is equal to xd upon d. Diffraction is bending of light along the edges. Fresnel diffraction. The source and screen are at finite distance. Fraunhofer diffraction. Source and screen are at infinite distance. Questions. Definition. Superposition principle. The combined effect of any number of waves at a point is obtained by a vector sum of displacements due to all other waves. When two or more waves interact in the region where they exist simultaneously, the resultant displacement at any point is vector sum of displacement due to component waves. For a distinct interference pattern, the two light sources should be equally bright. Explain. If two interfering light waves have same amplitude, then at points where waves are in opposite phase, there will be zero intensity, so the contrast in the interference pattern is increased and it will be more distinct. State and explain Rayleigh's criteria. The sharpness of central maximum of a diffraction pattern is measured by angular separation. Two diffraction patterns due to two-point sources are said to be just resolved if angular separation between central peaks is equal to minimum resolvable angular separation. They are well resolved if angular separation between central peaks is more than minimum resolvable angular separation. Give the theory of interference bands and obtain an expression for the fringe width. Consider point Q on screen at distance x. Light waves from S1 and S2 reach Q along paths S1Q and S2Q respectively. Path difference S2Q minus S1Q. The point Q is bright if path difference is 0 or integral multiple of lambda. S2Q minus S1Q is equal to n lambda. Point Q is dark if path difference is odd integral multiple of lambda by 2. S2Q minus S1Q is equal to 2m minus 1 multiplied by lambda upon 2. From diagram, S2q bracket square is equal to S2n bracket square plus Qn bracket square is equal to d square plus x plus d upon 2 bracket square. S1q bracket square is equal to S1n bracket square plus Qn bracket square is equal to d square plus x minus d upon 2 bracket square.